Hi everyone, welcome back to Art of the Part. In these next few videos, we're going to explore the business card holder case study, and we're going to assume that a customer sent us these files and they're asking for us to manufacture it. So what we're going to do is we're going to open up and take a look at the customer's SolidWorks part file, and we're going to step through their feature tree to see if we can offer any design revisions or optimizations that can make the part more manufacturable or machinable. And one thing that we want to keep in mind while we're going through this exercise is that we don't want to exclude or eliminate any of the functionality that the customer originally included with their file. So that's going to be a slot for the business cards themselves, and we're going to design around a standard 3.5 by 2-inch business card, as well as a short stack of sticky notes that's going to fit right here in that pocket. And then there's also this front slot here for a day of the week block so that every day you can kind of flip it over from Monday to Tuesday to Wednesday, as well as 2 holes here for either a Sharpie or a pen. We also want to include an area for the customer's name or their company, as well as a logo here on the back side. And then if we remove the sticky notes here, we're also going to have some branding underneath of where it was made and who made it. And we're going to put our class here on the back as well. So INTM 349 and 539. So I'm going to put back those sticky notes. This is what the whole assembly is going to look like when it's finished. And when you download this file, you're going to be looking at the business card holder, the customer revision, which is going to look something like this. And I'm just going to open this up for my assembly. So what I want to do is I want to take a look at some of these design details and see if I can just give like a blanket recommendation as like a starting point, and then we can kind of step through the feature tree and maybe identify some of those areas that we originally were looking at. So that said, one really helpful tool while looking at these parts, whether they're coming from a customer or maybe from somebody inside your organization, is if you go here into the top tab here, there's going to be a little evaluate tab. So there's features, sketches, and we've used both of those. Maybe you might have surfaces and then evaluate. So inside the evaluate tab, we're going to use the measure tool, which is just going to be a little tape measure. So if you click on this little tape measure here, it brings up a ruler as your mouse pointer. And what you can do is you can actually click from like 2 points, 2 edges, an edge to a point. You can grab like a radius or a diameter as well. But what we're going to investigate here is we're going to go from edge to edge and just see what these wall thicknesses are. So I'm going to click on that wall, or that edge rather, and this edge from that wall. And I'm getting a distance of 0.0938. And that's good. I would typically design around 0.093 as my minimum wall thickness whenever I'm dealing with a aluminum part coming out of 6061. I'd probably have like a range there from like 0.087 to like 0.093. Anything in between is pretty good. When you start getting thinner, you're gonna experience a lot more difficulties and problems that might occur, whether that would be chatter, the wall is going to be vibrating, the wall might actually try to pull away from the floor as well. And then if you're like drilling holes too, you might get like the material being pushed up to the surface and you'll see like a bump on the other side. So we want to try to maintain, like as I was saying, 0.087 to like 0.093 of wall thickness. And we're going to continue investigating these walls. So that one was good. I'm going to go from like this edge here, rather that edge to that edge. And you can see there I have a wall thickness of 0.093. That's not too bad. I'm going to look at the hole itself. So I'm going to go from this side here to that side. I have, again, a distance of 0.093. So it looks like whoever designed this part was designing around 0.093 as their wall thickness. However, I do see a little bit of an issue here because I can kind of just tell right off the bat that this is a little thin. So if I go from that edge to that edge on that front slot, yeah, that's 0.075. And then same thing on this edge to that edge, we're seeing a value again of 0.0743. So this is probably going to be one of those instances that I want to keep in the back of my mind as I'm going through the feature tree to at least address that and see if we can kind of thicken that up or change some of the geometry to make it seem thicker as well. All right. So one other consideration that we want to think about and look at is, do we have stock material on our shelves that is going to match or make the part that they're providing? So if I can use an existing stock material on my shelf, I can probably give them a better price because I don't have to go out and buy custom material and custom cut it and everything like that. So we can also use the measure tool here to kind of get like the X, Y, and Z extents. We can also go right into the Boss Extrude and like check the sketch as well. But while we're using this measure tool, let's go ahead and check that measurement here. And what I'm going to do is I'm going to grab this left side and then grab this right side. And I'm going to see the total length of the part, which is going to be 3.75. So my distance in X is 3.75. And then I'm going to grab from this face to this face. And this is going to be my distance in Y, and that's going to be 3 inches. So right now my part is 3.75 by 3, and then let's take a look at the height as well. So I'll grab the back face here to the top face there, and that's going to be 0.9375. So right now I know I have some material on our shelf for the 98431 part that we've explored quite thoroughly, and that material cut size is actually 3.75 by 3 by 1. So that's what I would probably use for this part if I was going to quote it out. However, I will not be able to clean up the part if I maintain these X and Y dimensions, because it would be size on size if it was 3 by 3.75. This 0.9375 dimension, the height of it, that's fine. We actually have 30 thousandths to clean up on the top and then 30 thousandths to clean up on the bottom. Total of 60 thousandths would be 0.9375 plus 60 thousandths, 1 inch. So we should probably take that same approach and try to change the extents of X and Y to be about 60 thousandths less. And before we make those changes, we should go and let the customer know, hey, we're thinking about making some changes to, make your part out of material that we already have on the shelf. Would that be acceptable? And they would say, maybe give me a revision and we can look at it. So right now we're giving the thumbs up to at least make some changes. So that said, I'm going to start walking through the customer's feature tree and seeing if I can offer those design revisions and optimizations. And we can easily click on a feature and edit it that way, but I want us to get in a good habit, especially when we're making changes at like the top of the feature tree, to not let it cause havoc all the way down the feature tree and just step through each feature as it comes. So right now, you may have not noticed this, and I may have covered this maybe in a previous class or exercise, but we have this rollback bar down here at the bottom of the feature tree. And we have the ability to kind of like step back into time and essentially suppress these features without deleting them. And if I grab the rollback bar, I think of it kind of like an equation. So it's like all of your variables are here, and this is like the bottom line of the equation, and then the finished product here is the part that we're seeing on the screen. So I'm going to continue to like move back through the variables or the numbers in my equation and just roll back to this feature. So if you hover over this rollback line, this blue line here at the bottom of the feature tree, there's like a little pinch on it. We can click, hold, and then drag it all the way up here to the Boss Extrude 1, which is going to be our first feature. And this is our X, Y, and Z extents in terms of the size of the part. And if I wanted to, I can click on the feature, or I can click on the part itself inside the viewport here, and it will identify and highlight what that feature is in the feature tree. But I want to edit the sketch, so I could either right-click here on the component itself and then edit the sketch of that right here with this little icon where it's like the sketch icon, but there's a pencil. Or the way that I prefer is if you go inside the feature tree, I can click on the expand, which is this little arrow next to the Boss Extrude or the feature or whatever we're looking at, and I can identify where that sketch is being driven from into the feature itself. So these two are linked right now. I'm going to right click on the sketch that's underneath the Boss Extrude, and I'm going to use the edit sketch icon here. So again, it's the sketch icon with a pencil in it. So I'm going to click edit sketch, and we already identified that X and Y should probably be updated to be about 60 thousandths less. So what I'm going to do is I'm going to actually use SolidWorks kind of like a calculator. So if I double click on one of these dimensions, I should get my modify box. And inside that modify box, I can actually type in, plus 1 inch or plus, a half inch. Or I can, in this instance, say minus, use the subtraction symbol, and then I'm going to type 0.0625. So I'm going to actually take off 60 thousandths in the total x direction. So I'll hit the green check mark. That dimension is now going to update as 3.6875. So you can kind of see where I was going at with that calculator function inside the modify box. We'll do the same thing here to 3. So I'll double click on 3. Same process. We'll do minus, so the subtraction symbol, 0.0625. And then we can hit the enter or the green check mark. And that should now update our values in x and y to be 3.6875 and then 2.9375. And again, the reason why we're doing that is because if I had a 3 by 3 3/4 block and I was trying to clean up on those outside edges, there's no guarantee that the part or like the stock material that I'm getting from either like a supplier, I'm getting like a bar and I'm cutting it into like separate lengths, is going to match up and give me enough cleanup to actually get that 3.75 or that 3.00. So I want to give enough material out here on the outside edge so that it can actually be removed so I don't have any like striping or cleanup issues. So we'll hit the green check mark and then complete that feature right there. And then I'll hit exit sketch. And that's going to bring me back out of the sketch into the viewport here with the feature rebuilt. And if you're not seeing like some of these features get rebuilt, maybe you make a change and the part didn't move or the feature didn't move itself, you can always rely on this rebuild function right here, which is the traffic light with like a red and a green light inside of it. And if you click on that, it'll actually rebuild your entire part or your feature tree. If that's still not working, the fail-safe method is to always use the hotkey force rebuild, which is control. If you hold down control and then hit the letter Q. So that's going to be a force rebuild. It's kind of like the, extra step when you're doing rebuilding. So if rebuild doesn't work, do a force rebuild, and that's control Q. All right, so we're going to continue to work our way down the feature tree and see if we need to make any changes on each individual feature. So right now I'm going to click, hold, and drag the rollback bar down now, and I'm going to see that I have a fillet there, and I don't really have any issues with that fillet. That fillet can stay the same. It's not going to cause any issues with the tools that I'm using. Same thing with this fillet tool, fillet 2 on the front side, no issues there. That's all seeming fine. Okay, this cut extrude 1 looks like it's going to be the first swivel or the first 5-axis rotation that we're going to come out, index, and cut. I can leave that alone for now. That doesn't seem like it's causing any issues, and it looks like there's a mirror right underneath it, which would then mirror that feature over there on the right side. And then these next features would be more or additional swivels. So this would be the first swivel. That would be the second swivel. This would be the third swivel. And inside our machine, those are all referred to as like cycle 800 rotations. So this feature that I've highlighted, you can actually see that it's highlighted, and it's actually highlighted there in the feature tree. So those two details are linked. But that's going to be the third swivel or the third cycle 800 rotation. This cut extrude 3, that's going to be the fourth cycle. The cut extrude 4, that's going to be where the nameplate is going. That's going to be the fifth cycle 800. And I'm not really seeing any issues right now with those. I think as is these features, they're pretty good. We might want to investigate when we put this in the work holding that we have enough distance from here to here, and we don't want to go below about like 3/8 because that's kind of where I have my safe zone set up, so I'm not cutting into my vise. So again, we're going to keep moving down. I'm going to get out of here, that evaluate, and then I'm going to move in here to the 1/2 inch diameter hole. Okay, so let's take a look at this 1/2 inch diameter hole. One thing that is going to not be a constant from like one machine shop to another machine shop is maybe the tip angles on the tools that they're using. So for example, I'm going to take a look and open up this hole diameter, this 1/2 inch hole diameter. I'll right click on it, and I'll kind of use this as an example as well. I can also right click or click on the feature here and right click it here and edit the feature right from the 3D geometry. So I could either use the uh, entry inside the feature tree, or I could use the piece of geometry itself. So I'll click on edit feature. I'll get inside of the feature itself. And I'm going to scroll down here and I'm going to look here for some of these custom sizing values. If you're not seeing the custom sizing where it has like the size of the diameter as well as the tip dimension angle, you might look at something that is, or you might open the properties bar and it might look something like this. However, if you want to see those values, you can always click on show custom sizing here on the left hand side. And then we can see what the customer in this instance put for that degree tip. So right now, 90 degrees, that's not very common. That's fine if they have that tool. However, in my tool library for the machine we're using, we actually are using this 1/2 inch drill with a 130 tip angle. So I will have to update that from 90 to 130. So let's go ahead and change that 90 degrees to update to what we're using, which is going to be 130 degrees. And then the depth is fine. I'm actually going to check that using the cross section here in just a second, but let's go ahead and complete this feature and hit the green check mark. We made the change for 130 degrees. We'll have that update. And we'll see if that 130 degrees will cause us any issues. So right now it's kind of difficult to get a good visualization of where the shoulder and the tip are going to be related. We could always go into the Evaluate tab and use the Measure tool. And for example, we could grab the tip of the drill and then the bottom of the face, and we could see that that's 0.843. I might want to see that a little bit thicker. And then we can also grab the shoulder here, and then I can grab the bottom face as well. Oops, move that up there. And I see that that's actually a little thin, 0.0603. I might want to thicken that up as well. Again, kind of hard to visualize that. So if we wanted to see like an inside look of that drilled hole, we have the ability, and I'm going to close out of my Evaluate here, or my Measure in the Evaluate tab, and I'm going to use the cross section. So that's up here in this little taskbar. And up here in this taskbar, we're going to look for this like bushing or like this donut that's kind of cut in half and we can see cross hatches in them. And we're going to click on the section view. It looks like it's defaulting here to the front plane. Notice that whenever you click on that icon there, you have the ability to toggle and cycle through multiple different planes. And then you can also rotate them around axes and change the degrees of them. However, we're going to stick here on the front plane. And if I wanted to, I could actually like type in the exact value of where that tip of the drill is intersecting. However, I'm going to make it easy on myself, and I'm going to just click and hold and drag on this arrow, and I can kind of cut through the part to that tip there, and I can kind of see what that geometry is going to look like inside of the part. And I'll hit the green check mark of that section view. So I can see, hey, I probably should bring this tip up a little bit so I get a little bit more thickness right there. Not a terrible issue, but just something to consider, and maybe try to give us some more space there, kind of like what I was saying, so that the backside of this doesn't bulge out because the material is getting pushed down and the wall thickness is too thin. So let's go ahead and raise this drill up about 30 thousandths and see if we can pick up at least 90 thousandths or like 87 thousandths there. So I'm going to right click on that feature and I'm going to edit the feature. So that's the 1/2 inch drill. And if I scroll down here, I see I have a blind dimension, and that blind dimension, we're going to change that and update it. We're going to do the same thing that we did before, where we kind of like move over to our cursor over to the end of the dimension, and we're going to type in a subtraction or a negative symbol, and then we're going to say negative 0.03125. And I hit enter. It didn't update here, but I saw it update in the graphics. So once I hit the green check mark, it's going to update, and I'm still inside that cross-section view. I can use the measure tool, and I can measure the tip to the back, or the tip to the bottom rather. I got 116 thousandths, and then the shoulder to the bottom as well. Yeah, I got 0.0874. That's well within my acceptable range here. So let's go ahead and consider that a valid update and continue on with the other features. So right now I'm still stuck inside of this view. I'm going to exit out of the measure tool here, but I'm still stuck inside of this cross section. And if I want to toggle outside of the cross section view, I'm just going to click on that icon once again, and that's going to bring me outside back into the full 3D model. All right, let's work our way down the feature tree. Looks like we're doing another mirror function, so it's just going to mirror this detail over to that. Okay, that's fine. All right, so now we have this slot where the business cards are going to be held. And there's a couple things that I'm just thinking of in the back of my mind as I'm talking through this. And the first issue here is this is an internal pocket, and that's going to take quite a bit of time to cut, especially if we have tight radius corners here. And I can investigate this, and once again I can click on the feature itself and I can kind of see some of the dimensions. I can right click on that blue area and I can hit edit sketch, and I can see here that my corner radii are set at 0.135. That's a good thing. So the customer said, hey, like, we know that there's like common tools, and we're going to make our radius a little bit bigger so our tool doesn't deadhead in those corners. So if I had 0.125 in that corner and I was using a 1/4 inch tool, my tool would deadhead in those corners and might cause it to chatter or chirp. But as long as we give like a little bit extra space, so if we had 0.125 plus, 10 thousandths, we have 0.135, that tool is going to now have at least some area for chip evacuation where it's not going to hit the corner and make a right hand turn. So it's actually going to have a radius that's going to smooth in here. So that's good. However, if we're using that tight radius, it's going to take a long time to cut this whole detail out, especially if we're limited to a 1/4 inch tool. And just to give you some reference here, I'm just going to draw this. You don't have to do it, but this is how big a 250 tool is going to be. So you can imagine how much time it's going to take to profile out or pocket out this whole detail with that 1/4 inch tool. And not only that, but how deep is this detail? I'm going to delete that and exit the sketch, and then I'm going to click on that cut extrude and then edit the feature to see how deep that is. So it's going to be a 750 deep cut. You can also use the evaluate, use your measure tool and grab the top face of that to the bottom face of that. And again, that's 750. So with how small that tool is, we're going to have to do a lot of cutting in here. So to alleviate that, we might go back to the customer and say, hey, we have an idea that maybe instead of making this a closed pocket here, maybe let's like blow out the edges and see if we can use a bigger tool and not have to deal with these radii. Additionally, as we were investigating, we found out that these wall thicknesses shrunk when we shrunk the part in X and Y. So instead of it being 90 thousandths like what we were looking at earlier, we have 60 thousandths. And then same thing here, 60 thousandths. So our wall thicknesses also shrunk. So do you mind, again, us going to the customer, do you mind if we make some changes to this detail to make it a little bit quicker? And I'll maybe show this when we're in Mastercam, but I'll keep this detail and I'll show you how long it takes, maybe like 7 to 10 minutes versus a bigger tool and how fast it can cut it as well. So that could be like maybe 3 minutes. So that's a lot of time savings, and maybe the customer might say, well, I can cut more parts per hour. That's going to bring my cost down, and I'm going to go ahead and approve that change. So we get a yes from the customer. We're going to make some changes here, and first thing I'm going to do is I'm actually going to edit this feature. So I'm going to edit the sketch. So I'll open up the Cut Extrude 5, or I'll right click here and I'll select Edit Sketch. I'll get inside of it, same thing. If I opened up the feature and I saw that sketch 8, I could right click on it and edit the sketch there. Oops, that was the plane. Edit the sketch there. All right, so like we said, we're going to blow out the walls. We're going to get rid of that detail and maybe use a bigger tool. So let's go ahead and extend out this slot here from 3.5625. I could either double click on it and use my mouse wheel to continue to increase the dimension, or I can just type in a blanket value here of like 4.5. Doesn't really matter. As long as the radius corners are past the edges of the part itself, we should be good. And then additionally, we want to make sure that we're a good distance away from the edges here so that we don't have too thin of a wall. So right now we are registering like 60 thousandths. Even if we came in and we were trying to like deburr it, or maybe someone had to polish it, that might actually like round over with how small it is. So we want to give at least that 90 thousandths. So I can put like a reference dimension using the Smart Dimension tool. You don't necessarily have to do this, but I can see that that's 0.0625, and you can see that this is a not driven dimension because it's gray versus black, which are driven. But if I double click on the 1.281, I'm going to again take off about 30 thousandths here, so I'll say minus 0.03125 and see what I picked up. And you can see that dimension now. I could also take a measurement inside of the evaluate, but that value is now going to be 0.09375. That's more than acceptable for our wall thickness as well. So we lengthened it, and then we also changed its position so that we have an appropriate wall thickness there. One other thing is, what tool are we going to use? So I'm going to hop back over here to the tool library that I have open in the Excel. So right now I have the 250 end mill identified for that slot. However, we're going to like blow out the walls now, and we could kind of approach it with a bigger tool. So I do have a 312 end mill. That's good. It's just going to maybe make that a little bit faster than the 250. I could use the 625 or the 5/8 end mills. However, I think that's going to be a little bit too big for our design. So let's go ahead and see what other options we have. And here at the 13th position, we have a 1/2-inch bull end mill. And we haven't used or explored or talked about a bull nose end mill yet. And I want to show you what a bull nose end mill looks like really quick before we go ahead and use this for this specific feature. So I found this image here on the internet, and you can see this is what a flat nose or a square end mill would look like. This is what we're typically using. You might be familiar with a ball nose end mill, which is a full radius from one side to the other side. So it's like that diameter and then the radius of it. And then a bull nose is kind of a combination between a flat nose end mill and then a ball nose end mill. And you can see that it's still square. However, we put a slight radius on each corner, or like the corner of that bottom round. And what that's going to do is it's actually going to project a radius in whatever detail it's cutting, much like a ball nose end mill would do. So a flat nose end mill would create a square corner, a square edge. Ball nose would kind of give you a full surface, and this bull nose would have a flat plus radii in the corners. So if I have a 1/2-inch bull nose end mill, I have to know what those radii are in the corners of it. So I'm going to minimize this, and I'm going to look here in my tool library and list and see what the radius is. So if I go over here to this column F, I know that my column G, my radius of this 1/2-inch ball mill or bull nose end mill is going to be 1/8, so 125. So if I use this tool, I have to put a 125 radius in the corners because that's what it's going to project. So I'm going to minimize this, and I'm also going to consider that if I am using a 1/2-inch end mill or 1/2-inch bull nose end mill, that I want to at least allow for 2 cleanup passes. So 1 cleanup pass on this side and 1 cleanup pass on this side. So I'm going to keep in mind or allot for about 30 thousandths of overlap. So I'm going to change this 1/2-inch dimension here from 0.5 to 0.53125. Or again, if you want to continue to use the calculator option, we can plus 0.03125. And you'll see that gets widened and updated. And then I'm going to hit exit sketch. And we'll just get in a good habit. Let's go ahead and rebuild. We can just rebuild that. And like I was talking about, if we are using that bull nose end mill, this can't be a square or a right angle corner now. So I have to now include a fillet on this edge and this edge. And that's going to be a 125 radius. So I'll move that there. And I'll go over here to the Features tab. I'll open up my fillet tool. So Features, Fillet. And this is the first detail that we're actually going to add that wasn't on the original part. So 0.125, we're going to select that edge as well as this edge right there. And then we'll hit the green check mark. So that's what the bullnose end mill is going to project and leave after it's done cutting. And using that big of a tool in comparison to the 250, I mean, we're using a tool that's almost twice as, I mean, it's exactly twice as big, but we're going to be able to take advantage of how big that tool is and really hog out some material here. Okay, so one thing that I noticed as we made that change and we made the slot a little bit bigger was the wall thickness from this side of the slot to the hole of the drill got thinned out quite a bit. It's pretty extreme. So I'm going to go back into Evaluate tab, take my measure tool, and I'll click on this diameter or this edge, and I'll grab this edge of the wall as well. And I'll see that I have about 31 thousandths there. I have to move this down about 60 thousandths if I want to maintain that 90 thousandths wall thickness. So I'm going to escape out of the measure tool, and I'm going to go into this feature here, that 1/2 inch drill, and I can right click on it, edit the feature. And one thing with these hole positions, if you remember, it's not going to be a dimension that we can access right from this type tab. We actually have to go over here to the positions tab, and we have to change the position there. So right now it's asking me if I want to include another drill. I can hit escape because I don't want to accidentally pop another drill in here. But I'm going to update and change this value of 0.4375. Double click on that. And like I was saying, we're just going to minus 0.0625 because we're going to move that down. We want to get that wall thickness back. It's going to get updated to 0.375. So then I can hit the green check mark. I can use my evaluate measure. I can grab that wall of the diameter of the drill, and I'll grab that wall there. Hey, look at that, 93 thousandths. We're set to jet. That's pretty good. So I'll hit escape, and then I'm going to continue to walk down the feature tree. So we're about halfway down the feature tree now, and we're getting close to the end. So we'll drag this down to cut extrude 6. All right, this is the pocket for the sticky notes. Let's go ahead and take some measurements with the evaluate measure, and then see what this wall thickness is there. So that's about 100 thousandths. That's pretty good. This right here, from there to there, I am seeing that's going to be about 185. So this is kind of giving me a hint of maybe I might be able to steal some of that geometry to kind of bring this up and maybe get some more flat out of that detail. However, we're just going to leave this pocket alone. I think this is fine. We might have to look at other features before we can kind of come back and change this. So let's keep moving down. So we're going to go into the cut extrude 7, and we'll notice that this detail is probably the worst of the lot in terms of the wall thickness. So if I grab the measure tool and I grab this edge to that edge, I notice that that wall thickness right there is 30 thousandths. And that is almost for sure going to round off if there's any additional finishing that needs to happen there. So why don't we maybe explore how we can change some of the geometry here. So this slot right now is designed for that hex block for the day of the week. And I'm going to go back to the customer and I'm going to say, hey, we're seeing some issues here. Do you mind if we change the slot for that hex block or hex block day of the week feature? And they're going to come back and they're going to say no in this instance because they've already manufactured or machined those hex blocks and they don't want to have to change or throw those parts out. So we must maintain this 1/2 inch detail. So I'm going to consider that as maybe a moot point in that we can't really change the geometry here other than maybe this corner. So we noticed that they made the corner up here to 135. However, they did miss a detail right there. That is 125. So if we want to use that 250 inch end mill, we're going to go ahead and try to open that up a little bit so it doesn't deadhead in those corners. So we'll make one single change on this slot. So we'll right click on it and we'll edit the sketch. and then we'll double click on that 125 and we'll just add plus 0.01. Okay. So the slot was updated slightly. We just changed the radius. However, this needs to stay as is in terms of its geometric detail. So what other ways can we kind of make up that distance? So we have this whole face here that we might be able to bring this closer and change maybe some of the angles or the positions to try to thin out this wall to thicken up these walls. So maybe let's start to investigate what we can do in terms of positioning with the angles. So back into those cycle 800 rotations. So I'm going to click on this detail here, and when I click on it, you'll notice that it highlights the cut extrude 3, and I could again either edit it or edit the sketch directly from the feature, or I can open it up in the feature tree. I'm actually going to hit the drop down or expand here of the extrude 3, find that it's linked to sketch 4, right click on that and edit the sketch. All right. So I knew that I had some distance here that I could kind of move this back. So why don't we change this value from 2.25, and we'll change that to 2.125. So we're going to pull an eighth back. However, when I change that, and I'm going to change it back here really quick just to show what these values are being updated to, I had a pretty good distance or dimension here of 4.412. And I want to at least keep like 3/8, so 0.375 from like the edge of this to the bottom of this, just so that I don't run into my work holding. I know that there's like a little ledge here in my work holding, and anything that comes below that, I just get a little bit too close for comfort. So I want to try to keep that dimension or that distance to about 0.375 or more. So if I change this back here to 2.125, that's the update that we just did, that's not really good. It's a little too close for comfort, like I was saying. We want this value to be around 375, and it went down to 0.335. So why don't we try to maybe change the angle of this 30 degrees? So I'm going to lessen the angle. I'm going to make it more shallow and see if I can get away from that 0.335 dimension. Maybe add a little bit more distance there. So make that 25 degrees, and it's kind of bringing me back to where I originally was. So I'm at 0.408, and that's a little bit better, and I'm away from my work holding, and I'm not going to accidentally run into it. So I'm going to hit the green check mark, and I'm going to exit the sketch. And since that was a detail that was maybe up here in the top of the feature tree or in the top end of the feature tree, and there are other details that are going to be affected and updated, why don't we just update this here using the rebuild button and make sure that everything got, rebuilt. So right now, I'm looking at this, and that one detail, just changing the degree, making it more shallow and moving it back, I was able to thin out this wall thickness as well as give some thickness here. And you can see that that value now is around that 0.093. So I think we did pretty good. I'm going to measure this one to that. And again, that's giving us a value of 0.093. However, we did get a little bit thinner here. And we could kind of start chasing our tail here and making slight adjustments, maybe bring this up. I'll just do that really quick. If we open up that cut extrude 6, and if we change this sketch 19, we have a value of 0.1094, and we can see this and that. If I change that to maybe 0.09375, we're starting to equal it out a little bit. Maybe we're going to go to like 0.096, or sorry, 0.09 even. Maybe that's more about evening out. However, again, this might be an instance where we're chasing our tail. And as I'm opening this up, and I did this on purpose because that's what I found online, was when I was initially speccing out the size of the the sticky notes, the dimensions that they listed were actually 1.437 by 1.937. So it was giving me a value of like 1 3/8 by 1 7/8, and I was trying to give a little bit of slop there. so that the sticky notes can move around. However, when I purchased all these sticky notes, I took some measurements. And I'm assuming this is what the customer did, is that they looked online, they found the measurements, and that's what they were referencing. But if I actually measure the physical parts out, they read 2 by 1.5. So we will actually have to then go back into this and update it to be 1.5 by 2. So we were kind of close to the end, and this happens all the time in the professional world. I finish making all my changes and updates, and then I measure one component that maybe we overlooked, and hey, we missed a detail. So I want us to kind of be accepting of that and get used to that, because it's going to come up whether you like it or not. So I'm going to update these dimensions, and I'm going to change that 1.9375. So I'll double click on that to 2, and then I'll add the 30 thousandths there. So I'll 2.0325. And then I'll change this 1.4375 dimension from 1.437 to, I'll have to actually change it to 1.5 plus 0.03125. And now this is actually creating more havoc. So all these changes that we just made are now going to have to be readdressed. However, when I hit exit sketch here and I rebuild, I'm still happy with how this front detail looks. However, I might have to make some compromises now on using that bold nose end mill, because I don't think I have enough room or flat to kind of equal this all out. Like I said, you're more than welcome to kind of play around with the details and see what you get, but at least for this exercise and how I'm administrating it, I'm actually going to thin out this wall. I'm going to do, thin out the slot, and then not use that bullnose end mill, and then revert back to not the same end mill size of the 250. I'm going to step it up 1 and go to the 312. So in this instance, we're going to click on this detail. I'm going to go to Cut Extrude 5. I'm going to edit that sketch. And instead of it being 0.531, I can now shrink it up a little bit and use a smaller tool, which is going to be that 312 end mill. So I'll double click on that 0.53125. I'm going to change this to be 0.40625. See if I can pick up some of that distance again. Hit the exit sketch. All right. So I now have to remove this radius because I really don't have a tool that can project that radius in there anymore. So we're going to, again, get used to some of these functions or features, but if I click on this detail, it'll highlight here in the feature tree, or I could right-click it on the feature tree or right-click the detail itself, and then I have the option to suppress it. So suppress is a little bit different than rolling things back. Suppressing will allow the entire feature tree to rebuild, but it's going to remove that one feature without deleting it. So I still have the option to come back and look at that if I want. However, I'm just going to suppress this, and it's going to get rid of that feature, but it's going to keep it in the feature tree, and it's going to gray it out. All right, now let's see if we can move this pocket here up to kind of equal out these distances and get our 90 thousandths distance of wall thickness. So sketch 19 in Cut Extrude 6. Edit the sketch. All right, so I have 116 there, 161 there, and I have about 32 there. Let's double click this dimension, and let's just maybe scroll our mouse wheel up and down and see if we find something that's close. And I know this off the top of my head, but we're going to change this value here to be 0.03125. And it's kind of balance out these two values of these wall thicknesses to 90 thousandths there and about 100 thousandths there. If you wanted to get a little bit closer, you could obviously kind of, massage it a little bit more. However, I'm going to leave that position. So I'm going to hit exit sketch. I'm going to have that rebuild. And then we are going to use the rebuild command once again. And then there are two other details now that I'm noticing that might have to be updated. One is that this wall now is just getting a little bit too close to that. So I might want to change these cycle 800s to be a little bit shallower, as well as I want to establish this whole position maybe up a little bit more. So I'm going to start off with this detail here So I can always click on it and it's going to identify what that detail is on the left-hand side of the feature tree. So that cut extrude 1, I'm going to go in there and I'm going to edit it. So that 0.75, I'm going to take off about 60 thousandths again. So I'm going to, go minus subtraction symbol 0.0625, bring that over to 0.6825, hit exit sketch. That's looking a little bit more even now. We're getting a more uniform scaling in terms of the wall thicknesses. If I take out my measure tool and I go from here to here, now I'm picking up about 100 thousandths. So we're kind of maintaining anywhere between like 100 thousandths and 90 thousandths for these cycle 800 rotations as it relates to this pocket here. And then the last thing that I have to do is I have to move this both in X and Y now in terms of over and then up. So if we click on this detail, I will edit it, go into the positions once again. I'm going to hit escape right off the bat because I don't want to place another drill hole. And I just have to change these values. So I'm going to go back and forth a couple times, maybe find these values. I'll go back to its original 0.4375, see if that kind of evens it out. And in this detail, I might make this like 0.4375 as well. So that's getting a little bit too close, maybe 0.46875. That's kind of centering it up a little bit. Let's see what that looks like and then take another measurement. So we'll hit the green check mark, green check mark. Okay, it looks pretty good in X. However, in Y, we want to bring it up a little bit closer. So I'm going to take a measurement there. I'm at a 156. So we're going to take that value and try to bring it down to like 90 thousandths. So let's go ahead and, click on that detail, that 1/2 inch drill. Hit escape once again. I'll maybe make this plus 0.09375, or sorry, plus 0.0625. Bring it up to 1/2 inch, and this detail is 0.468. Green check mark. Measure that wall to that wall. Now I'm back there at that 0.938, and I can measure this to there. I have about 75 there to there. We have about 82. So if we wanted to split the difference there, we could go back into that detail one last time. Positions. And I could just maybe change this to 0.453125. So I'm taking about 15 thousandths off. Green check mark, green check mark. And that's going to center it just a little bit better. So you can see there what havoc can arise when you start making these changes and maybe making design changes around certain toolings. But all in all, I'm pretty happy with what we did with our revisions here. We are able to use material that we have on the shelf, as well as we're going to use the tools that we have in the machine. And we even made one change here after everything was completed and done, and we double checked what these sticky notes were in size so that the part could actually function in its final state. So I'm going to continue to just roll down the feature tree here and finish up this exercise, but right now we just have the product info, we have the name on the front side, the logo on the back side, and then we just cut extrude that with a split, and then we're going to add a chamfer there on the back. So all in all, I think we did a pretty good job in making this more manufacturable. Even though that we weren't able to use the bullnose end mill, we're still able to like blow out these sidewalls here and maybe approach this with maybe like a dynamic milling approach that might make it more easier to machine. And we updated the drill holes to our correct drill tip, as well as updated the pocket here so that we could go ahead and mill out these corners with the 250 tool. And before I end this lesson and conversation here, I just want everyone to kind of keep in mind why we added these little earmarks here. Is because if we had and I'm going to hop back over here, I'm going to control tab over to the assembly here, some of this stuff got moved around. Hide that. But if I had a square corner here, and I'm going to just suppress this. If we had a square corner, sticky notes, and if I go into the mates of the sticky notes, suppress those. If I had a square corner going into that edge, I would never be able to mill that square corner out, especially in a pocket. So to maintain that we have, the ability to line this up from side to side, we want to put this little earmark here as well as a little earmark here so that we can pull the tool out. So this will allow us to have a nice square corner for this part to nest up against. So that's why we have these little earmarks on the corners to allow the tool to swing as well as to provide, if I just draw a shape here too, this might be easier to understand. You can see that these sticky notes are cut square, so that square would then fit inside that pocket there. Because if I try to cut this square pocket exactly, the radius of my tool is going to project no matter what, and I'll probably see something that looks more like this, and the sticky note will not sit flat in those corners. All right, so I'm going to end the exercise there, or the video there, and we're going to continue on in the next video and maybe talk about some configurations and how to set up our Cycle 800s and how to separate them so that we can pull them into drawings and make it easier for us to program on the machine as well. So thanks for watching. I'll catch you in the next one.